Alright, hello. This is going to be a quick video. We're going to look at some advice for the programming assessment that people have to take. So in the course policies for computer science, you have the programming assessment. There's a couple of example files here and some information on the frequently asked questions. And then there's some more examples on the server, for those that have login to the server, so I'm going to look at that. Alright, in this directory here we have a file example questions. It has a bunch of additional sample questions that you can try, and if you ever want more because you've done them all, then just ask me to put more in. We also have a couple of versions of the actual assessment that was given. There's a few of them here, and we're going to look at one of those in particular as an example. Let's see. This one here from November 13th. There are two different versions of the November 13th assessment, and this is the one we'll look at. I also have here some notes that we'll look at. Under November 13th, there's some answers, my versions of the answers. Under the test directory, there are correct working programs for some of the stuff in the examples. So I could go to, this says 5A2. 5A2 is there. You could read the question and then go in the test and run it. Looks like it's taking an argument of some kind. So then you can try it out to see what it's supposed to be producing. Alright, but I want to look at this exam here, and I've taken some notes in the, let's make this instead of notes, call it advice. Alright, so there's advice on each particular problem and then some general advice. Let's look at each problem. So the first problem is always going to be a loop. It's generally not to require any user input at all. You just hard code the values that you are supposed to do. So this one here is asking to print perfect cubes, 1, 8, 27. And what's the next perfect cube? This is 3 cubes, the next one is 4 cubes, which is 64, and it's asking me to print them up to 432. We can look at what the answers look like. So November 13th, 1. So and the problem here, the main is already there, we just have to give a loop. So we start at 1. Keep going as long as I cubed as at most 432, add by 1, print I cubed. Alright, and for this particular one, some people were doing while I is less than 432. I don't think the problem was super clear, so that would have been alright. Alright, so the advice for number 1, no user input. That's basically it, and then you're going to have a loop. While loop or for loop, sometimes with an if inside. Second problem is always read from standard input, which you can do with scanf or getchar or fgetc. Those are all options. So you generally want to have memorized this program right here. Let me say what it is, and then you can pause to take a look at it. So we have an integer we call fgetc with stdin that will be reading from the keyboard. So we read that character into ch. If there's no character to read because they typed Control D or the file that's being read is done with no more characters, it returns EOF. There it is. So this ch will go one character at a time through the input. And then inside here we would do something with the character. There's a few examples here. So this one here prints the character. This one checks to see if it's X and counts how many X's. All right, but in general, you have to start with at least this, and then you're going to add to it to do whatever the problem's asking. This one here is asking to print every third line. So the first line, and then the fourth, and then the seventh. You can take a pause and think about what needs to happen to be able to do that. And we can look at my solution. So basically, we need to be counting the lines. I start with a line number that's 1, and then every time the character is a new line character, increase the line by 1. And then we look at line mod 3. So line mod 3 will be 1 when line is 1, or 4, or 7. If that's the case, then we print the character. So when we're on those multiples of 3 plus 1. All right, so this follows a general pattern. You read a character, you're going to do something inside of it. We have to store something here about what line we're on. That happens sometimes. Okay, so you might want to pause, and if you don't have this memorized, look at it, and then see if you can write it down without looking back. You just have to have that memorized. Next problem is a linked list problem, and generally it's going to ask you to go through the linked list and do something. So the general template for looking through a linked list, you start with the head of the linked list. You keep going as long as what you're looking at is not null. And after each iteration of the loop, you go to the next item. And the exact name of next here will depend on this definition of the structure. All right, so generally you're going to do, this is your loop through a linked list, and you'll do something with each node in the for loop, and the problem will tell you. It just depends on the problem. Sometimes you'll need to store some information to initialize something. If you're looking for the maximum, then you would initialize the maximum to the head. Inside you would do some comparison. This particular problem here is asking to print the linked list as long as it's in strictly decreasing order. So we look at it and we want to check against the 3. We always print the first one, and then when we get to the second one, check to see is it strictly less than the one before it. You could pause and try to think how you would get that into this loop. I'll show you mine. All right, here's mine. So there's that part is pretty much typically not going to change. And then inside of here, I'm printing the data and I'm comparing the previous to the data at this particular node. And then for that to work, the previous has to be set to the previous value. When I'm looking at 2, I need previous to be 3. And the way that I do that is by having this line here. So after I'm done with PTR in this iteration of the loop, I save that data value into previous. So then the next time through, previous is the one before it. And you could trace through this on paper to convince yourself of that. All right, so we always print the first item. If the pointer is head, we print it, it's the first item. Or if it's not head, then previous has been set up, and we want to see if that's greater. Okay. Number 4 is always a binary search tree problem. Typically, it's going to ask you to traverse the tree, either the entire tree or a particular path. And this is your template for traversing a binary search tree. We have the node type here with the root pointer, name of the function, whatever it happens to be. There might be a return type, or there might not, depending on what the function is supposed to do. And then inside the function, there's 3 parts really. So when you're null, that means you're not a tree, you're empty. Then just return, or maybe return 0, depending on what the problem's asking for. And then you always do the left side, so you recursively call the function that you're writing on the left side and on the right side. And then you typically will do something based on the left, whatever was returned from the left and the right and this current node. Okay, so that's really 4 parts. When you're null, you return, traverse the left, traverse the right, and then do something with that stuff. So the left and the right return values and your own data. And like I said, you need to think about this, pause the video for a second, and make sure that you agree with that as a general kind of structure. This particular problem is asking to count how many nodes have 2 children. Left and right are both not null. Okay, so if we're looking over here, if we're counting, this return type is going to be an integer. You're going to return 0 when there's nothing. These would be the counts for the left and the right side. And then you would add those up, and then you need to count 1 for yourself if left and right are both not null. You can see that. So here we have, if it's null, we return 0. We do the left, save the value, do the right, save the count, and then I count 1 for myself if both my left and right are not null. If they're both not null, I have 1 for the count, otherwise it will be 0, and then I return all of that. So I have myself, my left, and my right. Okay, that's number 4, and you really need to have this here memorized. Number 5 is typically bit operations, and you should have memorized all the bit operations that are possible, and you should know the size of numbers we see on our computer currently, 8 bits for care, and etc. So I'm not going to tell you all those. You can look those up or ask somebody. All right, so you're typically going to have to do some of this stuff to pull out some bits or do something with some bits. Sometimes you'll have to do a loop through the bits. This one here is asking to pull out the 3rd byte. Each hexadecimal number, each hexadecimal digit is 4 bits. 2 of them is 1 byte, so this would be the byte that we want to pull out if we're looking at the hex. And there's different ways to do that. You could do shifting to get rid of the 78. So shift right, and then shift back the other way to get rid of those, and then shift back again to put this at the right there. Or we could do AND with FF in this position. Let's look at what we have here. So there's an unsigned integer x. There's 2 different ways here. So this one shifts to the right. That puts the 56 in the rightmost position, which is what we want. And then AND with FF. So FF at the end, that means anything else will be handed off to be 0. This is a way to do it with bit shifting. Okay, general advice. To pass, you should remember that you need exactly 3 exactly correct, and at least 2 halves. So you have to be careful not to get a 0. If you have something that is clearly not in the right direction, clearly says you probably don't understand the question, or you're really not on the right path, that's a 0, so you want to be careful of that. And you only get full credit if there's nothing wrong, nothing at all. You want to be very careful to check over your answers. On terms of practicing, you need to do this on paper. A lot of you are used to doing coding on the computer, and it helps you find a lot of your problems where you compile, there's an error, you look at the error message, you go find it. So this is, you don't have the compiler, you have to look at the code. So you want to practice that. You go into the examples, you pick whatever kind of question you're working on, pick one of the examples, and do it. And for number 1, 2, and 5, you can run it. So you pick this, you write it down on paper, you check it yourself on paper, you try to be very careful in paying attention to details. And then after you think it's done for sure, that's what you would have turned in, you go ahead and type it into the computer exactly like you have on paper and see what happens. You probably made a mistake, and then you can do this with multiple different problems and see what kinds of mistakes you tend to be making that you need to keep in mind when you're not on the computer. Number 3 and number 4, you don't really have code that this fits inside of, so you would have to ask somebody. You can ask one of the faculty or one of the lab assistants in the lab to take a look at what you came up with. Let's see, any other advice? You can read that. All right, that's quick answers to one of them and advice. Good luck.